Hello, hello everyone. I'm Dr. M. Fatima. Today I'm taking non-inverting amplifier. Non-inverting amplifier, actually in this configuration, the input signal is applied to the positive terminal of the op-amp, that is non-inverting terminal of the op-amp, which means that the output gain of the amplifier becomes positive, and the result of this is that the output signal is in phase with the input signal. So this is the diagram. This is showing the op-amp. Positive terminal is showing the non-inverting terminal and negative terminal showing inverting terminal. Here the input is given to this positive terminal. So when this input is given to this operation amplifier on the positive terminal, this amplify the input signal without any phase. That is, the signal is in phase with the input signal. Now the open loop non-inverting amplifier, this is the circuit diagram of the open loop non-inverting amplifier. You can see here the input voltage is connected to the positive terminal of the op-amp and negative terminal is grounded. The voltage available at the negative terminal is taken as V2 and the voltage at the positive terminal is taken as V1. The output is taken from here. VCC and VE are connected for the biasing. So V1 is equal to input voltage Vin. So we know that output voltage is equal to A multiplied by V1 minus V2. V1 is this voltage and V2 is this voltage, and A is the open loop gain of the op-amp. Now we can say V1 is equal to Vin and V2 is equal to 0 since it is grounded. So V2 equal to 0. Now put these values of V1 and V2 in this equation. So this output voltage becomes V0 equal to A Vin minus 0. So this is equal to V0 equal to A Vin. This is the output voltage of the open loop in non-inverting amplifier. Here the positive is coming at the output. It means the output is in phase with the input signal. Now to a numerical, determine the output voltage of open loop non-inverting amplifier if input voltage is 1 microvolt. Draw the input and output waveforms. We know the output voltage for the non-inverting amplifier is equal to V0 equal to A multiplied by Vin. Here the input voltage is 1 microvolt and the gain of the op-amp for 741 IC is 2 into 10 raised to 5. This is open loop gain for the 741 IC. Input voltage is 1 microvolt, that is 1 into 10 raised to minus 6. So put these values here. So I wrote here, so the value comes, this is 1 into 10 raised to minus 6 multiplied by 2 into 10 raised to 5. So this comes out to be 0.2 volt actually. So this is equal to 0.2 volt. Now you see the waveforms here. In this waveform, you can see the input is given. This is yellow color is showing the input waveform, and this dark pink color waveform shows the output voltage, output waveform of non-inverting amplifier. So this input is given, this wave is given to the positive terminal of the non-inverting amplifier. This amplifies the signal and keeps this output signal in phase of this input signal. Take another numerical. Determine the output voltage of open loop non-inverting amplifier if input voltage is 1 volt. Draw the input and output waveforms. Now the solution of this, we know that the output voltage is equal to A multiplied by Vin. Here the input voltage is 1 volt and A, we know that A is equal to 2 into 10 raised to 5 for open loop op-amp 741 IC. Put these values here. 2 into 10 raised to 5 multiplied by 1. So this comes out to be 2 into 10 raised to 5. So this is a theoretical value. Actually, this is very high voltage and this is not possible in the op-amp to get it. The operation amplifier can get the value less than VCC, and this value is called plus V saturation or minus V saturation. That is the voltage swing of the op-amp. So here the output voltage is equal to 14 volts. So this is the practical value. The output of this output of this non-inverting amplifier will be 14 volt, that is the plus V saturation or voltage swing of the 741 IC. This 2 into 10 raised to 5, this output voltage is not possible to get in any op-amp circuit. The output can be available, this will be less than VCC and which is equal to 14 volt. Generally in 741 IC, the VCC is 15 volt and the saturation voltage is 14 volts. So here I wrote V not equal to 14 volts. Now see the waveforms, this is the input waveform. Here the sine wave is given. The output is very, very high, 2 into 10 raised to 5, but the available output is only 14 volts. So the signal is cut down at the plus V saturation, from at plus V saturation at minus V saturation. So this AC signal or the sine wave is converted into the square wave. The output of this numerical is plus V saturation and minus V saturation. So the sine wave is converted into a square wave. Now non-inverting amplifier with feedback. Here you can see the feedback is connected at the negative terminal of the op-amp and at the positive terminal of the op-amp, the input voltage input supply is connected. R2 RF consists of feedback network, comprises feedback network. The voltage present here at the positive terminal is denoted by V1, which is equal to Vin. This is a potential divider network which is drawn here. See here, this is a potential divider network R2 RF. See here, this voltage, see out at this point the voltage is available. This is V2 voltage and which is the voltage drop across this. Here this is taken as V1. This voltage V1 is taken here. Okay. Now this voltage V1 is equal to V out multiplied by R2 upon R2 plus RF because of this potential divider network. So V1 is equal to R2 upon R2 plus RF multiplied by V out. Now the ideal summing point because of this V1 becomes equal to, this V1 becomes equal to V in. So put this V1 equal to V in here. So it is equal to V in equal to R2 upon R2 plus RF into V out. Now take out the value V out by V in, which is equal to gain of the non-inverting amplifier. So it is equal to R2 plus RF upon R2, that is 1 plus RF upon R2. This is the gain of the non-inverting amplifier. It means the non-inverting amplifier depends on the value of feedback resistance and R2 resistance. That is, the gain of the inverting amplifier depends on the feedback network. Here the positive signs appear, there is no negative sign. That's why the output voltage will be in phase of input voltage. Now see here, this is a diagram for the non-inverting amplifier in input and output waveform where the gain is varying. So see this orange color waveform is showing the input signal and the purple color waveform shows the output signal. This input signal is given to the non-inverting amplifier. This signal is amplified and it is in phase with this input signal. But here you can see the amplitude is varying. It means the value, if the value of the RF and R1R changes, the gain will be changed. So the output voltage value will be changed. So this is possible to change the amplification of the output of the non-inverting amplifier, but the phase will not be changed by changing the value of RF and R1. Thank you. This completes this lecture.